So A and B both are the subset. So we know that the probability, total probability of a sample is 1. The probability lies from 0 to 1 as the whole area of the distribution, the data or observation lies under 1. And then we know that if events are mutually exclusive, so combined probability is just an addition of all the probabilities. That's also known as addition rule. What we are talking about addition rule. So in addition rule, we have two cases, mutually exclusive and not mutually exclusive. For mutually exclusive, we have this one, and for not mutually exclusive, we have this one. So in not mutually exclusive, there is something common. So we can say A and B are the subset of a sample space where probability of A or B, A union B, equal probability of A plus probability of B minus probability of A intersection B. Let's take an example of the die. A is 1, 3, 5. B is 1, 2, 3, 5. So B is a set of prime number. A is a set of odd number. So what is A? What is common? A intersection B. Common is 1, 3, 5. Right? So you can find out probability of A union B. Here, probability of A, which is 1 by 2, plus probability of B, which is 4 by 6, means 2 by 3, minus probability of A intersection B, which is 1, 3, and 5. And it's also 1 by 2. So it's again 2 by 3. So that's the probability of A union B. So these are the two rules. And if we extend it, we can further. So here in mutually exclusive, we can say it is equal to probability of A1 plus probability of A2 because they are independent. So there is nothing common, and so on, probability of A. And we will see through an example later. In this case, if there is 3, A, B, and C are the subset of sample space, then what is the probability, combined probability of non-mutually exclusive, or what is the additional rule for non-mutually exclusive? So here we can have probability of A union B union C equal probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C. So what is common in A and B? What is common in event A and C? What is common in event B and C? So that's how we have two rules. Let's take a simple example. This is in case of 3. And if we have 4 events like A, B, C, and D, then we can go further. So first plus, then we have minus, and then we again have plus, right? So plus probability of B intersection D. So here will be minus plus probability of D minus this, and we can have combination of this, and we can solve it with the minus plus plus minus rule. So these are the addition rule. This is the rule of a probability of total sample space, and this is like the probability lies between 0 and 1. Got it? Is it clear? So let's move on then. Now we will see some examples. And before going for the example, let me take you to consider or to understand the concept of or complementary rule. So here, this is also known as law of complements or complete. Why it's not working properly? So there in either you exist or you don't exist, right? So the students who are in the class, they are in the class, and the students who aren't in the class, they aren't in the class. So either you are at one place or you are in another place. So the complement means not having. So a complement of event A is the set of all outcomes in the sample space that are not included in event A. Do you understand this? Like you have two things. Either you have head or you have tail. If you have head, it means there is no tail, right? If you have one, it means there is no two, no three, no four, no five, no six in an example of a die. So if event is A, if you are interested in only heads, so the complement is tail, right? If you are interested in only dice showing one, then complement is the dice showing 2, 3, 4, 5, 6. So complement, because we know that A sum of all probabilities is 1, so if A complement is the rest of the sample space, it should be equal to 1, right? The probability, I'm talking about the probability. So that is the complement. That's the complement law. So complement means A bar is in such a way that W belongs to the sample space where W doesn't belong to A. So this is going to be complement. So in this case, what is but belongs to A, and this is A complement. So if I just shade it, so the space which I'm marking with yellow, that's the complement. So if this is the A, if this one is A, the rest one is a complement. Hope you have understood. So this is A, rest is complement. So total overall, the probability is 1. We know that. So let's see. Yeah. Now you understand this one. So again, I repeat that something occur is event A, so not occurring is event complement of A. It's denoted by A prime and read it as an A prime. So let's see. That's true. Probability of A plus probability of A prime is 1. That's true. And probability of A is, this is really common, because if you know, we so we can learn from the example of a die that event A is 2, 4, 6, and if the complement will be 1, 3, 6. If A is 1, 3, 1, 3, 5, so A complement is 2, 4, 6. So this one, probability of A is 0.5, so probability of A complement is 0.5. So together, if we add up, it can give us the whole sample space. It's really important because if we know one probability, we can calculate the other one probability by subtracting it from 1. That's why it's really easy to calculate. If you know one, you can get the other one. In any case, either if you have known probability of A, you can get probability of A complement, or if you have probability of A complement, you can get probability of A. Let's say, so probability P assigns to, these are the properties I just explained you on the board. This is also known as addition rule. So this is for mutually exclusive. This is for not mutually exclusive. Got it? Now let's talk about the conditional probability. What is conditional probability? This is really commonly used probability. Remember, in normal probability, we assume that we have all possible outcome in our space, in our sample space. Whereas in conditional probability is the probability of an event occurring given that another event has already occurred. So this is the whole sample space. In normal probability, we consider the whole sample space area, right? Every area here, here, to find out the probability. But we narrow down. We narrow down in conditional probability. We just need to, because here one information is given, or one event has already been occurred, and that information we already know. And so it's really easier because now we have to deal with the less sample space. So I can say that I have to deal with now this sample space to get the probability of A given B. How it can be calculated? Let's see. This is really real. This is very realistic and useful in real life scenario because mostly we deal with the conditional probabilities. So you can define that is the probability of an event occurring given that another event has already occurred. It's can be denoted as okay, I will show you on the board. Um, you can see the camera, right? No, you cannot. So, now you can see. So I'm gonna raise this. Okay. So what is conditional probability? In conditional probability, you find out probability of one event given the information of another event. Whenever we are calculating conditional probabilities, it is based on the given information, this information, right? We need to find out the probability of another event. If any information is given, it means that our sample space is skewed. So normally, if our sample space is like this one, and if we have an extra event information is given, so it becomes a bit skewed, right? It becomes narrow down the information, because before, as I told you, we were dealing whole sample space. Now I'm just dealing this sample space, because this event has already occurred. B event has already occurred. So I have to find out the A such that given B. So actually what I want to do, if I can tell you clearly with this diagram, so this is B. It's already happened. So I need to find out the probability of this area. This one. Because this is already information is given. So how to do that? So that's why it becomes skewed. So now I don't consider these sample space. I consider these sample space. And it gets smaller. Mathematically, it's given as A given B, or you can also in another, it depends like what outcome you are looking for. B given A. And it can be given as probability of A and B. Remember, in probability, what does and means? Intersection. Divided by probability of B. In this case, is the same. The denominator is same, A and B, given that probability of A. So you need to calculate the A intersection B upon probability of A and probability of A intersection B upon probability of B. Let's see it more clearly with an example. So if we have chips, when we play with casino, so we can have so now you understood this one, right? So these are the notations. Let's take an example. Now there are 5 red chips is given, 4 blue chips. You are in a casino to play something. You have 5 red in a bag. You have 5 red chips, 4 blue chips, and 6 white chips. So what is the total sample space? So total sample space here is 10 and 5, 15, right? That's the total sample space in the basket. Now 2 chips are randomly selected. Further, find the probability that the second chip is red. So we know that we have to find the probability that second chip is red, given that first chip is blue. Now the information about the first chip has already occurred. So we have already selected, we have took one chip from the bag, and it gives us the blue. Now we know that. So what is the probability of having second chip as a red one? So now, because 1 is gone, so now the rest of the sample space is 14, right? Because 1 is out of the box. So probability of red given blue gonna be how many red? Red are 5 chips. So 5 by 14. Do you understand? That's one example. Then we will do a second example where you can see this formula happening. Because the first chip is selected and not replaced, there are only 14 chips remaining. So remember here, once you picked something, you don't replace it in the bag. If you replace it, then you have to take the probability again from the 15 chips. So that's almost 35% or 36% chances that the second chip will gonna be the red one. So you see how interesting it is? You can play. Let's take another example of 100 college students were surveyed and asked how many hours a week they spent on studying. So the results are in below table. I will show you the table. Find the probability that students spend more than 10 hours and the student is a male. Now here you can see, and you can also see the whiteboard. You can see the whiteboard, right? So in that case, we know that this is the table: male, female, total, less than study, less than 5, less than 5 hours, 5 to 10 hours, more than 10 hours, total. Right, so this is the table. It's given a total 49 and female 51, 100. And here 13, 11, 22, 24, 16, 14. So this is the information. So what is the sample space here? What is the sample space? 100, right? Oh, what is event A? Event A, that probability that student spends more than 10 hours. So studying more than 10 hours. What is probability B? Probability B is that the student is male. Now we can calculate the probability A, probability B. So what are the students? How many students studying more than 10 hours? 30 students. So 30 by 100, it's like 30%, right? Probability. Male, what is the possibility of male? Is 49 by 100. 49%. That we know. What is common? That how many people, what is probability of A intersection B? How many students who are studying more than 10 and are male? So 16. 16 by 100. 16%. So we know the conditional probability. So here probability, we need to find out the probability A given B, which is probability of A intersection B by probability of B, right? Now we know that this is 16% or 16 by 100. So we can say 16 by 100 by, what is the probability of B? B is 49 by 100. 100 cancel out, so it will be 16 by 49. So when you solve it, you can get it. So the sample space consists of 49 So now you understood. Right, so here 49 male students, and out of 49, 16 spend more than. So I just showed you on the board how to find in using this formula, but because it was simple, you can also look at the table and you can find out that what is the probability. So probability of more than 10 hours and male is 16 by 49, which is almost 32.7%. So there are 33%, almost 33% that student is a male and he's studying more than 10 hours. Now, can you tell me quickly who can find out the probability that the student spends more than 10 hours and the student is female? So what is common? 14. So it will be 14 out by 51. Because students are female, is the probability is 51 by 100, and the common is like 14 by 100. So 100 cancel out, so it will be 14 by 51, which you can find out, right? So hope you have understood. So you can play other, you can assume other, you can ask your students, your classmates, your first friend sitting next to you, that okay, you tell me that how the students, females probability, what is the probability of a female student studying from 5 to 10? So you can find out all these probabilities, different probabilities. Now let's talk about the concept of independent event and multiplication, rule of multiplication. This is here where we can use the card. So one, you know the addition rule, you know the conditional probability. Now we're gonna talk about that how to get like an independent event. So two events are independent if occurrence of one event doesn't affect the probability of the other event, then they are independent. It means, what does it mean? Let me show you through the whiteboard. Oops. Yeah. So let's talk about first independent. Independent means they have nothing common. They have nothing to do with each other. They're two different events. So remember, in multiplication rule is, so let's first talk about independent. Then we go. Independent rule. So two events, A and B, if B is not impacting A, event A, then we call it independent. So can I say that if probability of A given B and B has no impact on A, which means it can give me the probability of A. So in this case, if the probability of A given B equals probability of A, in this case, these two variables are independent variables. They are two different variables, outcomes. Or you can say P of B given A give us the probability of B. If it's not true, then they are dependent. So in previous example, we were talking about the dependency because they are not equal, but in this case, they are equal. So let's go further about the multiplicative rule because we're gonna use this in multiplicative rule. So multiplicative rule is based whether your events are dependent or independent, right? So in this case, they are independent. A given B is not equal to probability of A or probability of B given A means probability of B. It means there is something common between them because we know conditional probability A given B is probability of A intersection B upon probability of B, right? So there must be something common. Then we have dependent. In this case, if we consider it has a conditional probability, then we can define independent and dependent as above. So then multiplicative rule can be very simple. A and B will occur in sequence. In sequence means I'm talking about dependence. So probability of A given B, dependent means this is the condition, right? So in that case, probability of A and B, because they are dependent, is first probability of B happen, and then probability of A given B happen. Because it's not equal to A, so in this case, A and B are dependent. Whereas in case of independent, probability of A and B, probability of A times probability of B, because then there is nothing common between A and B. So these are the multiplicative rule. You will be more clear when we will do example about roll of a dice. So let's go back to the screen. Now look at this example. So you understand this. So they are dependent if there is something, and they are independent. Then this rule can be simplified to probability of A into probability of B, because this is going to be equal to probability of B, because there is nothing common. We already have learned this. Let's take an example. Let's say two cards are selected without replacement. We don't replace from a deck. Find the probability of selecting diamond and then selecting a spade. So selecting diamond and then selecting a spade. I'm not so good in making diagram. Okay, anyway. So how many cards total in a deck? How many cards in a deck? 52, right? I will also share the screen as well with you. So now you can see the cards. So we have total 52 cards. So sample space 52. Now in case we say that selecting a diamond, this is diamond, right? Selecting a diamond, this is diamond card, and this is the spade card. So we have to select what is the probability of diamond and spade together. So in this case, because the card is not replaced, the event are dependent, probability of diamond and spade. So it's probability of diamond given that probability of spade given that diamond. So the probability of diamond is 13 by 52 because there are 13 diamond cards in this deck. But I'm not replacing this one. So now I have 51 cards with me. And what is the probability that next card is a spade? The next card is a spade. So this possibility is 13 out of 51 because one card is already gone. We don't replace. So total, when you solve it, there is like 6% chance. So when we play in a casino, we do one thing, we put like a poker and we just select one. So now I know that there are two of diamonds. So I calculate what should be the next two cards. And if I see the third one, second one, then I calculate what it should be the possibility or probability of the second card. And that's how I can put more bet, or I can just quit the game without losing money. So that's why probability is a real life scenario. Let's take another example of a die is rolled and 2 coins are tossed. Find the probability. Now this die is one event and coin is another event, and both event has no connection with each other. It means they are independent. They have nothing to do with each other. So, but the deck, these cards were dependent because they are from the same sample space. So find the probability of rolling a 5 and flipping 2 tails. Rolling a 5, we have this probability 1 by 6. Whether or not the roll is a 5 or not, we don't care. The probability of tail is half. We know that because coin has nothing to do. So probability of 5 and then flip a coin of tail and then tail. So we are combining the probability or multiplying the probabilities. So that's why it's known as multiplicative rule. So probability of 5, probability of tail, probability of tail. There is like 4% chance that if I do 2 events, so I can get 5 and I can also get 2 tails at the same time. So this is about multiplication rule. Some example, let's see, we will do some example now. Let's see how much time we have. Okay, we just do a couple of example. The following frequency distribution represent the age of students in a statistics class. So you're gonna solve this, okay? So I'm asking you, what is the probability that a student is between 26 and 33 years old? So what is the probability? Tell me. Quickly solve this one. Quickly solve this one. Oops. Who can solve this? 26 and 33. What is the probability? 8. What is the frequency? 8. We know the empirical rule. What is the sum of f? You have to calculate sum of f. 13 and 8, 21. 21 and 7, 28 and 2, 30. So what is the probability of this age? 8 by 30. Simple. Why are you not replying me? Yeah. See, there's another example out of 36. So next time we will do some examples and we will cover other concepts as well.